Hello guys, welcome back to our YouTube series on C programming. Alright, in today's video, I'm going to teach you how to make decisions in C. And this will be our course outline. We're going to be looking at if statements, if-else statements, the if-else ladder, or the else-if ladder rather, and we're also going to look at switch statements. But before we get into this video, let's test your brain real quick. Suppose I give you a student score, say 75. Can you write a program that will decide if that student has passed or failed? I don't know, but anyway, don't just think, okay? Write your answer in the comment section and I'll come back to it later. You should note that in today's video, you will not just be watching, you are going to be coding with me. I will give you challenges along the way and I want you to pause, think, and try. And when you do that, you compare your answers with me and you write them in the comment section. Alright? So let's dive straight away into our video. The first part of this video, we're going to be looking at the if statement. The if statement is used to make the simplest decisions in C. How do you write the if statement in C? The general syntax is as follows. You put an if, you open braces, and inside you put the condition that you'll be testing, and then you open curly braces, and then you put the code that has to be executed. So this is the basic syntax of an if statement in C. So you put if condition and then the code to be executed. So let's take an example. In this our example, we have to get somebody's age, and if that age is greater than 18, we are going to print out the person is an adult. Therefore, we declare a variable called age, so int age. Let's assign a value to it, let's say 18. And then now we write an if statement. We say if, we open our brackets, we put our condition. In this case, our condition is if age is greater or equal to 18, is greater than or equals to 18, then the program should print out that the person is an adult. So printf, you are an adult, \n semicolon. Alright, so let's quickly run this and see what we get. Alright, so as you can see, it works. You are an adult because age is actually greater than or equal to 18. What if the person's age is 15? So let's change the value of age here. Let's put, say, 15. Let's quickly run the code and see what happens. You see, we get no output. So we need to modify this code such that if we enter 15, it gives us an alternative output. And this is where the else statement comes in. So generally, when you say if age is greater than 18, it means that if this condition is true. So what if the condition is false? That is where we now use the else. And so we introduce the else. We say else. This time around, there's no need to put another condition because already this condition is false. So the first condition up is false. So down, we just put an alternative action that takes place if the condition up is not true. So we just put else. I'll just copy this and we paste it here. You are not an adult. So let's modify that. You are not an adult. So let's quickly run this. We leave age at 15, as you can see. So you now see you are not an adult. So let's modify this program such that the user should enter his or her age and then the program should be the one to decide. So let's change this. So let's just declare age up here. And in order for the user to enter his or her age, we simply write the printf statement informing the user that we're going to be needing their age. So we do that. Enter your age, \n, semicolon. Now, in order for us to actually get that age, remember we have to use scanf. So scanf %d, since our age was an integer, and now we call the reference operator ampersand age. Now this program has been modified such that the user can enter any value for their age, and then the program will decide whether they are not an adult or if they are an adult. So this statement here that I'm highlighting checks if the condition is true, and if the condition is true, then this block of code here is executed, and if this condition is not true, then this other block of code here is executed. So basically that is how we implement an if else statement. All right, but what if we have various conditions, not just two? In this situation we have only two alternatives: you are an adult or you are not an adult. What if we have three conditions to check or four conditions to check? Can you guess what the code will be, or how we can modify this code to look like? Please write your answer in the comment section if you know what the answer is going to be. Okay, let's suppose that the grading system of an examination is such that if you get a score above 80, if you get a score above 80, if you get a score above 80, then, so if score is greater than or equal to 80, then you get an excellent remark. And if the score is greater than or equals to 50, so if score is greater than or equal to 50, you get a pass. So here is a pass, here is an excellent. And what if score is less than 50? So if score is less than 50, you get a fail. So now let's go ahead and program this examination system idea. So let's get it. So we're just going to change, let's do it from scratch, please. So remember our main idea there, our main variable there is score. So int score, int score. Now we prompt the user to enter the score. Enter your score, \n, semicolon. Now we get the score using our scanf. Our score is an integer, so we use a %d, call the ampersand, call the reference operator ampersand, and oh sorry, not h, it's supposed to be score, semicolon. Now this is where we get to make that decision. We say if, remember, let's get the general idea again. If score is greater than 80, the student gets an excellent remark. If the score is greater than or equal to 50, the student gets a pass remark. And if that score is less than 50, the student gets a fail. So that is how it's going to work. So let's try it. So if we put our condition, score is greater than or equal to 80, we open our curly braces, printf, excellent, or excellent score, semicolon. So this is the first condition. Now, how do we implement that second condition where the score is greater than or equal to 50? So this time around, we don't just use else, since we have more than one condition. So we just put else, we use else if, This time the condition is if score is greater than or equal to 50, if score is greater than or equal to 50, we print, we output pass backslash n semicolon. Now we have evaluated two of our conditions and one condition is left. Usually if you have three conditions to verify, when you use if, just use else at the last condition. So it means that if all these two conditions fail, what then should happen? So else we simply print fail backslash n semicolon. All right, so let's run the code and see what we get for the various results. So we compile and we run. Oh, sorry, there was supposed to be an F here, so it's gonna be supposed to be print F, and that is correct. Now enter your score. Let's say we enter 75. You see 75 is less than 80, and so but it's greater than 50, so the student has passed. Okay, let's do 85. Excellent score. So I've gotten pass, we've gotten excellent. Now let's do 49. 49 is less than 50, so we're supposed to get a fail. Let's do 49. And of course, we got a fail. Alright, so at this stage, you have known how to do if else statements, and you have also known how to do the else if ladder, or what we call in programming a cascading if. So using this idea, or what we have learned so far, I would like for us to solve a real maths problem, the a quadratic equation. Let's write a program that solves a quadratic equation. Of course, the program should be able to 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 give us the result for the quadratic equation and equally tells us the nature of the root. Please, if you know how to do this, I would like you to comment yes in the comment section. You write your name and where you are watching from, so that in our next video we're going to give you a shout out. Okay, so let's get to our quadratic problem. Before we try to program this, it will be important for us to understand how a quadratic equation is solved. A quadratic equation can be solved using various methods. But the method we're going to be implementing here is solving using the quadratic formula. The quadratic formula says that b squared says that x, remember we have two values for x, x1 and x2, but in general x is equals to, or x1, let's do that, x1 is equals to minus b plus the square root, let me use sqrt for square root, plus the square root of b squared, that is b times b, of b squared minus 4ac. And of course, all of this is divided by 2a. So we divide this by 2a, 2a, sorry, 2 times a, 2 times a. So this is x1. Remember, a quadratic equation has two formulas, sorry, two answers. So this is x1, and this will be the formula for x2. We'll just simply change this to a minus. So this is going to be minus b minus the square root of b squared minus 4ac, all divided by 2a. So this is what we're going to be working with. And then we know that for the nature of roots, we know that if the discriminant of a quadratic equation is greater than 0, if the discriminant is greater than 0, we know that the roots are what? If the discriminant is greater than 0, then the roots are real and distinct. So the roots are real and distinct. If the discriminant is equal to 0, if the discriminant is equal to 0, we know that the roots are real and equal. And lastly, if the discriminant is less than 0, we know that if the discriminant is less than 0, we know that the roots are imaginary. And quick one, the discriminant is b squared minus 4ac. Quick one, we know that the formula for discriminant, we also know that the formula for discriminant is equal to b squared, that is b times b times b, minus 4ac. Sorry, not an underscore, it's supposed to be a minus. Alright, so this is what we are looking at. Remember, always advise that before you get to program anything, it's advisable to be able to solve that problem on paper first before you get to program it. So this is what our system looks like. We're going to calculate the roots of the quadratic equation, which are x1 and x2. Sorry, x1 and x2. We're going to calculate the roots of the quadratic equation, which are x1 and x2. And we're going to determine the nature of the roots. And if the roots, and in order for us to determine the nature of the roots, we have to determine the discriminant of that quadratic equation, and that is gotten by using b squared minus 4ac. And if the discriminant is greater than 0, we're going to say that the roots are real and distinct. If the discriminant is equal to 0, we're going to say that the roots are equal. They are real and equal. And if the discriminant is less than 0, then we know that the roots are imaginary. Please, if you know how to write this program using this idea, you can comment yes in the comment section and maybe post a screenshot of your code. Let's implement this draft into a real program. But before we do that, I'd like to point out a few things. First, notice that I've used something new today, the sqrt function. Sqrt simply stands for square root, and square root is not defined in the stdio header file. So we're going to be needing a new header file, or another header file that has this function, and that header file is the math.h header file. And then another thing I want to point out is that we have to check the number of variables we're going to be needing. We're going to be needing x1 and x2 to hold our roots. We're going to be needing a, b, and c, as well as we're going to be needing a variable for the discriminant. So let's get to that. So first thing first, let's include the math.h header file. This header file is used to perform mathematical operations such as square root, trigonometric functions, logarithms, and all what you know in math. Okay, at this point, let's declare our variables. So int a, b, c. Let's declare them as integers. And let's use float for x1, x2, and discriminants. Now let's write statements for getting a, b, and c. So printf, enter value for a, \n, semicolon, scanf. We use percentage d since a was declared as an integer, ampersand a, semicolon. So I'm just going to copy this and paste it several times. I'm just going to copy that and paste several times, and then we'll simply modify the variables. Okay, so we're going to change here. We put b, and we equally modify here with b. Here we do c, and here we do c. Now let's determine the value of roots. So I'll just comment this out. Value of roots. So I'll just come to this my draft, and I'll copy this for x1. So this is x1, control V. So our x1 is this. You can end up with a semicolon. Let's print it. Printf x1 is equals to percentage %f. Since we declared it as a float, percentage %f backslash n comma x1 and semicolon. We do the same for x2. Control V. I'll just change this value here to x2, and I'll change this plus sign to minus, and I change this to x2 as well. Change this to x2. Alright, so at this level we should be able to get the value of the various roots. So let's try an equation such as x squared minus 4. If we have a quadratic equation such as x squared minus 4, a will be 1, b is 0, and c is negative 4. So let's go ahead and run this. Hopefully no errors here. So a is 1, b is 0, and c is negative 4. And of course x1 is 2 and x2 is minus 2, which is very correct. If you solve that quadratic, you're going to see that x1 is going to be 2 and x2 will be minus 2. Now, so that's our test quadratic throughout this problem. Let's determine the nature of the roots. Remember, this is where the decision making comes in. We have 3 conditions to verify. Let's get back to our draft. This is the nature of roots. For the nature of roots, we have that if this is greater than 0, then the roots are distinct. So before we do this, let's just copy this out and paste in our code. This was my draft that I'm using. So let's just add this here. Nature of roots. So this is equals to b times b minus 4ac semicolon. Now we use our cascading if. If we put our condition, this is greater than or equal to 0. If this is greater than, no, it's not greater than or equal to. If this is greater than 0, yeah, greater than 0. If this is greater than 0, then we are supposed to print f roots are real and distinct. Roots are real and distinct. Backslash n semicolon. The roots are real and distinct. Do you mind if we print the value of the roots first, so that maybe somebody might want to know the value? So let's print out the value of the roots first. Control C. So let's just copy this and print f. This is equals to %f comma this. So we're printing the value of discriminant here so that we should all know what that value is going to give us. Okay, so roots are real and distinct. So if it's greater than 0. Now, what if it is equal to 0? That's the second condition, right? If this is equal to 0, so the roots are real and equal. So else, remember how we did it the last time. Else if, open braces, this is equal to 0, roots are real and equal. And then lastly, else roots are imaginary or complex. So this is a simple quadratic program. Let's run this and see what we get. Okay, remember our test equation, x squared minus 4. So our quadratic is x squared minus 4, and therefore a is 1, b is 0, and c is negative 4. So we enter 1 for a, we enter 0 for b, and we enter negative 4 for c. And of course, x is 1 is equal to 2, x2 is equal to minus 2, our discriminant is 16, and the roots are real and distinct. I would like you to try this problem, write down, copy down this code, and try out with various values or different quadratic equations. Try out with different quadratic equations, and then you give me your answers below. Please, for every quadratic equation, write the quadratic equation you're using for the problem, and then you give me the results you get in the comment section. All right, thank you for watching. The next thing I would like us to be looking at is the switch statement.